Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In our previous episode, we celebrated the 5-year anniversary of the debut of Space News from the Electric Universe with a comprehensive overview of the historic space missions to comets. This overview provides a compelling demonstration of the respective successes and failures of the theoretical predictions of standard comet theory versus those of the electric universe. None of the mission findings support the standard view of comets as electrically inert, dirty snowballs that slowly sublimate as they move toward the sun. All of the findings support the electrical view of comets as dry, rocky bodies that become electrically active in response to their changing plasma environments. The startling truth today is that institutional science no longer has a coherent theory of comets in the face of insurmountable falsifying evidence. Nevertheless, we are still told that comets are conglomerates of ice and dust that formed 4.5 billion years ago, the leftovers of a solar system formed in a swirling disk of gas and dust. However, many decades before the technically remarkable missions to comets, the basis already existed for a radically different view of comets. In fact, perhaps unbeknownst to many scientists and laypersons, electrical theories of comets have been proposed by dozens of researchers dating back centuries. As author and historian Hannes Teger has demonstrated in his remarkable historical research, for at least the last 2.5 centuries, various astronomers, physicists, and natural philosophers have hypothesized that cometary phenomena are basically electrical. An electric comet means that the assumption of charge neutrality applied to space objects at all scales cannot be correct. But the case for electrical comet activity has only grown stronger with ever finer technological data. Comets have been a source of mystery for centuries, and there's no debate that mankind viewed comets with awe and terror for millennia. In modern times, the list of observed cometary phenomena that defy all standard explanation is tremendously daunting. Let us begin our systematic analysis of the mysteries, comparing the standard predictions and explanations versus those of the electric universe. Comets breaking apart. In the 20th century, with the dawn of the space age came unprecedented opportunities to observe increasingly remote comets as they moved toward our region of the solar system. An imposing enigma quickly emerged. Astronomers began observing comets that broke apart or disintegrated at amazingly vast distances from the Sun, for no readily apparent reason. As far back as 1957, comet Virtanen split while inside the orbit of Saturn, well over 800 million miles from the Sun. And a similar thing happened to comet Biela-Lambert. In 1976, Comet West never approached closer than 30 million kilometers from the Sun. So when a disruption occurred and the comet split into 4 fragments, astronomers were shocked. More recently, the explosive breakup of Comet Linear in the summer of 2000 provoked even greater amazement. The event occurred well over 100 million kilometers from the Sun. In fact, Carl Sagan and Anne Druyan, authors of the book Comet, reported that 80% of comets that split do so when they are far from the Sun. In stark contrast, scientists must explain the question of why some comets pass extremely close to the Sun and yet do not disintegrate. Obviously unexpected if comets are sublimating ice balls. An extreme example of this puzzle came in 2011, when the perihelion of the Lovejoy comet C2011W3 brought it to within 140,000 kilometers of the Sun's surface. As seen in this video, the comet survived intact after more than 1 hour in the Sun's corona. In a paper in the 1960s, astronomer Dr. Brian G. Marsden highlighted the unsolved mystery of comet fragmentation. He noted not only the problem of the fragmenting comets' distance from the Sun, but also the relative velocity of their separation, far greater than could be due to solar heating. He wrote, "Although most of the comets observed to split have done so for no obvious reason, one really does require an explanation when the velocity of separation is some 20% of the velocity of the comet itself. A collision with some asteroidal object at 200 AU from the Sun and 100 AU above the ecliptic plane, even though it would only have to happen once, is scarcely worthy of serious consideration. But more than half a century after the publication of Marsden's paper, astronomers certainly do still entertain extraordinarily improbable cometary collisions, such as the case with the comet 67P, whose double-lobed form astronomers have attributed to two comets colliding, then sticking together for some reason. The aforementioned Sagan and Druyan may have found a clue to the unresolved problem of comet splitting, though without recognizing its significance. They wrote, "Splitting and jetting may be connected. At the moment Comet West split, the individual fragments brightened noticeably and propelled large quantities of dust into space in the first of some dozen bursts. The same was also true for the breakup of Comet Linear in 2000. But why would high-velocity jets and explosions of dust traveling at supersonic speeds precede the fragmentation of a comet nucleus?" In the electrical model of comets, the answer is obvious. Comets have never been successfully explained in simple mechanical terms because they are electrified bodies orbiting within the plasma environment of the Sun. Like any good conductor, the electric field within the plasma is very low. But unlike good metal conductors, the solar plasma is of extremely low density, and therefore its current carrying ability is limited. Comets must adjust to the changing plasma potential as they move radially toward or away from the Sun. On the long, slow journey through the outer reaches of the solar system, the adjustment is not so difficult. But it does often involve visible electrical discharge effects as a comet races through the inner solar system. The comet nucleus behaves like a capacitor, and if a discharge occurs within the capacitor, it can explode violently. This does explain why outbursts that precede comet fragmentation are far more energetic than could possibly be explained by sublimating ices. The electric universe interpretation can also explain the sudden and unexpected brightening of comets at extraordinary distances from the Sun. In October of 2007, the comet Holmes 17P stunned astronomers around the world when it suddenly brightened by a factor of 1,000,000. In less than 24 hours, it grew from a small 17th magnitude comet to a magnitude of 2.5, so large it was easily visible to the naked eye on Earth. Holmes's coma continued expanding until by mid-November of 2007, it had become the largest object in the solar system, visibly larger than the Sun. The coma's diameter had grown from 28,000 kilometers to 7 million kilometers. At the time of Holmes's extraordinary display, the comet was actually moving away from the Sun, and therefore cooling. Among the common sense questions posed by the enigma, how does such a gravitationally minuscule body hold in place a uniform spherical coma 7 million kilometers in diameter? If Holmes's flare-up was a result of a collapse or explosion, as some scientists speculated, why was the ejected material not asymmetrical, as one would anticipate from an explosion? Why did the claimed explosion not produce a variety of fragmentary sizes, instead of the extremely fine dust that was actually observed? What explosive event could have caused the comet to illuminate for months, rather than the seconds typical of an explosion's luminescence? Why did the comet's gaseous, dusty, spherical cloud persist for months, rather than dispersing quickly away from the comet? Unfortunately, the science media and the astronomical community had barely anything to say about Comet Holmes. This seems nearly unbelievable, considering the enormous interest the comet generated around the world. As Thunderbolt's contributor Scott Wall explained in his 2008 article, Comet Holmes, a media non-event. You might think that this remarkable behavior would be big news, particularly among astronomers. A prominent astronomy magazine recently published their top 10 news stories of 2007. Surprisingly, this spectacular comet was not named as the top story. It didn't even finish in the top 10. In fact, the entire magazine completely ignored the comet. There was not even an editorial comment. Additionally, there was little, if any, newspaper or TV coverage. Holmes's spectacular brightening was reminiscent of a, quote, surprising display several years earlier from the comet Hale-Bopp. As seen in the photo on your screen, Hale-Bopp was too far from the Sun for a, quote, dirty snowball to melt, but it already displayed 7 jets. 4 years after Hale-Bopp left the inner solar system, it was still active. It displayed a coma, a fan-shaped dust tail, and an ion tail, even though it was farther from the Sun than Jupiter, Saturn, or even Uranus. The comet's tail was shrinking, but it was still about 5 times longer than the distance between the Earth and the Moon. At such a distance, if solar heating could melt ice, then one would expect that the icy moons of Saturn and Jupiter would be as dry as our own moon. Again, the electric comet theory states that dramatic cometary displays arise from the electrical interaction between the comet and the solar discharge plasma. In fact, considerable evidence exists that the electrical relationship between comets and the Sun is not one-sided. Dating back decades, astronomers have noted numerous so-called coincidental incidents of CMEs corresponding with an approaching comet. The consensus theory remains that no connection between the two events can exist because of comet's insignificant size compared to the Sun. However, many recent findings lend credence to the electrical interpretation. Consider scientists' baffling discovery in 2007 that the comet McNaught was somehow able to modulate the solar wind. NASA's Ulysses spacecraft encountered the comet when it was passing close to the planet Mars. Scientists detected that the comet's tail had slowed the solar wind to half its normal speed. Space science professor Dr. Michael Comey said of the discovery, "This was very surprising to me. Way past the orbit of Mars, the solar wind felt the disturbance of this little comet. It will be a serious challenge for us theoreticians and computer modelers to figure out the physics." But perhaps the greatest confirmation that comets are electrically charged bodies is the spectacular displays, completely unexpected by astronomers, of comets that have closely approached planets in modern times. The most dramatic such display came in 1994 as the comet Shoemaker-Levy 9 approached the gas giant Jupiter. Prior to the encounter, astronomers predicted that the comet's influence on Jupiter would likely be as trivial as pebbles falling into an ocean. But as we have repeatedly outlined on this series, the effects were both more dramatic and generally inexplicable in standard reasoning. The anomalies included unusual and energetic auroral activity immediately after the quote impact of the largest Shoemaker-Levy 9 fragment, as well as the disruption and amazing brightening of radiation belts, and unexpected X-ray emissions. As Michael Klein of JPL said in an analysis of the events, "Never in 23 years of Jupiter observations have we seen such a rapid and intense increase in radio emission. Extra electrons were supplied by a source which is a mystery." Visit the link in the description box of this video for Wal Thornhill's in-depth analysis of the Shoemaker-Levy 9 puzzle. More recently, comet sighting Spring presented a similar shock to astronomers in its close encounter with the planet Mars. NASA's MAVEN spacecraft measured the effects of the encounter on the Martian atmosphere. According to a NASA report, debris from the comet added a temporary and very strong layer of ions to the ionosphere, the electrically charged layer high above Mars. MAVEN team member Jared Espley said of the comet's astonishing influence, "We think the encounter blew away part of Mars's upper atmosphere, much like a strong solar storm would. The main action took place during the comet's closest approach, but the planet's magnetosphere began to feel some effects as soon as it entered the outer edge of the comet's coma." This brief summary offers only a glimpse of the still growing list of quote surprising comet discoveries. But is it a coincidence that the electric comet theory predicts and explains all of the so-called mysteries? As we will see in our next episode commemorating the 5-year anniversary of this series, comets are just one of countless phenomena that only affirm the electrical nature of the universe.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.